Hello, let's continue our advanced Sudoku series with Valtari by Shye. This is puzzle number 6 of chapter 4 of the Sudokult Gospel document. I have seen this puzzle solved before because Simon did it on Cracking the Cryptic a while ago. And also we covered it on Sudokult discussion. So I know a lot about this puzzle. It's still going to be quasi-life solved because it's not like I've practiced it recently, but I do know generally what's going on. But I'm trying to cover every single puzzle in this document in case you haven't seen it before. So I am going to cover this one. If you would like to try it yourself first, there is a link in the description, as well as a link to the entire document. And I'm going to get started right now. All right. Let's actually get started by doing getting as much info as we can, per usual. I do have 2 1s looking up here, so 1's in one of these 2. This entire column has only 4 digits left, so let's look at that. We need a 2, 3, 4, and 7. So that cleans up quite nicely. Well, except for this cell here. This is 1, 2, 3, 4. That's not 1, that's not 1, 2. 5 is in one of these 2. We have 2 1s looking into here, so 1's in one of these 2. What else we have? 6s are down here. Let me just make sure I didn't miss anything obvious. 5 digits here, okay. 8s are down here. 5, 6. 6s are up here somewhere. 8s we got. Okay, down here, 1's 3. Okay, 4 is in one of these 2. 5s are... Oh, 5 actually. This 5 looks down, this 5 looks down, this 5 looks in. We actually get a digit. That's 5. Nice. What else can we do? This 8? No. Okay, let's look a little bit more vertically. These 7s look up. There's a 7 in one of these 2. I'm not sure there's anything like super great to find from basics. 6 is in one of these 2. All right. Even if I'm missing something, I don't think it's super important. So the important cells are these 1, 2, 3, 4s. So how do we want to go about this? I'm tempted to try to do this with set. So but this is an exo set. And I think viewing it as set can make things a little easier in certain cases. So let's think about how we would do it with set. That might be interesting because I haven't thought about that. We may have covered that in the Sudokult discussion, but I don't remember. I think we might have. So okay. Let's try this column. See, but this has 1, 2, 6. This column. Usually we would use 3 columns with an exo set. Usually we'd use 3 columns that all avoid our target cell stack. Or 3 rows, I suppose, could work too. So I'm seeing these givens and these givens line up, but I'm thinking maybe we want to use this column as well. Oh no, yeah, one of the columns goes through and avoids the 2 target cells, I'm pretty sure. All right. Sorry, it's been a week since I recorded tiles. I'm trying to remember. Okay, and so now what we want to do is we want to try to bring in, so what do we have here? We've got 1, 2, 6. We've got 1, 6, 6, 3, 7. Okay, so yeah, so 1, 2, 5, 6, 7, 8. So the digits we're missing are 3, 4. And I feel like for the exo set we should be focusing on 1, 2, 3, 4s, but maybe I missed in which columns to do. In fact, I think I might have. I think I might want to do instead. I want to do these columns. which these still line up, kind of. We have this kind of offset. I think this looks better, though, because these are mostly 5, 6, 7, 8s. We have a singular 1 here, but otherwise, these are from 5, 6, 7, 8s. So now what we want to do is try to bring in 1, 2, 3, 4s in 3 rows. And these are going to avoid... Is it 4 rows that we want to do? Is this an imbalanced set? Let's avoid this row. Let's do these 3 rows. Let's do this in purple. Okay, so what I'm doing here is set. So let's talk about what this means in case somehow this is the first video you're seeing, or maybe you just want a refresher on set. That's absolutely fine. So set equivalence theory. The idea is we are equivocating 2 different sets of cells to make them have the same digits as each other. So the easiest way is to start with groups of cells that definitely have the same digits as each other. So green versus purple. I would say that the digits that go in green are the exact same digits that go in purple, because the digits that go in green are 3 sets of 1 to 9, because I put in 3 columns. And the digits that go in purple are 3 sets of 1 to 9, because it's 3 rows. So 3 columns have the same digits as 3 rows. It's almost trivial, right? Yes, of course, 1 to 9, 1 to 9, 1 to 9, and 1 to 9, 1 to 9, 1 to 9. But let's think about if I were to take that green set, put them in a bag, and the purple set and put them in a bag, right? I'd have 3 sets of 1 to 9 in my green bag and 3 sets of 1 to 9 in my purple bag. Well, what happens if I remove this cell from it? Well, this cell, whatever digit goes in it, it's going to be the same digit in purple and green because it overlaps. You can see it's both purple and green. So if I were to fish in here and whatever tile it ends up being, I take that out and I throw it out. Then I fish in here and I throw out the same tile. I've removed the same digit from both. And so these sets without this one are still equivalent. We've kind of thrown out the information of it's exactly what digits go in them, but we do know that whatever digits go in them are still the same. And we can repeat that for all of these. If I can do it right. Oh, come on. All right. Slow is fast, fast is slow. There we go. So purple and green are still the same exact 2 sets of digits. Interestingly, I can't cancel out a 1 because there is no 1 in purple right now. I hope I did the right set here. If not, we'll experiment with other ones. But okay, so let's think about what we're saying here. So we've got a bunch of 2s, 3s, and 4s. Okay, I do have 5s I can cancel out, so let's do that. I do have a 6 I can cancel out. We know there's a 6 in one of these purples, and that cancels with this one. But that's not super helpful at the moment, just because... I do have a 1 in purple here, which is going to cancel with this one. Okay, so I'm not going to arbitrarily pick one to cancel, but this one is accounted for, and then one of these 6s is accounted for. But anyway, let's think about these 2s, 3s, and 4s. I have 2 2s, 2 3s, and 2 4s that need to go into green somewhere. Now, notice how none of our givens in green are 2, 3, or 4 yet. So the question we want to ask is, where do 2 2s, 2 3s, and 2 4s go into green? And the key here is to think about these 2 cells, which I'll put in blue, because these 2 cells are from 2, 3, 4. If these 2 cells are from 2, 3, 4, that means that whatever these 2 blue cells are, they need to appear in green twice, but cannot go in these 2 cells. So where are they going to go in green? And the answer is somewhere in here. We're going to have 2 of each of these cells. So think about it. One of them can go in this row, but then the other ones have to go here. So whatever this one is, let's actually give this a different color. Let's give this orange. Where does orange go in green, right? Well, it needs to appear twice. So orange goes once in here. So one of these is going to be orange. And then the other one is going to go in one of these 2. One of those 2 is going to be orange. And then the blue, same deal. One of them can be down here, and then one of them can go up here. Now, the next question we want to ask is, what happens if I were to make both of these orange? Well, if both of these were orange, I still need 2 blues in green, and they'd both have to go in this row. It's the only open spots left. And that's not going to work. I can't put 2 blues in the same row. So the conclusion is, first of all, this is a blue-orange pair. which means they're only from 2, 3, 4. So this cannot be 6, and that places this 6. Additionally, we're going to need a blue and an orange down here somewhere. So blue and orange are going to end up down here. So we're going to end up with the 2, 3, 4s, 2 of 2, 3, 4 down here. We can also go backwards, and we can conclude something about all of these digits. We've accounted for the 1 and we've accounted for the 6, but we need 5. We need 2 5s, a 6, a 7, 2 8s, and 2 9s. So let's count that. That's 1, 2. Let's just count all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 digits. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How did that happen? Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm not sure where that degree of freedom's coming from. I'm sorry. It's from the extra digit here, right? Whatever extra digit here is going to end up in purple as well, right? Sorry about that. So what can we say about this extra digit? We can say it's not a 6. So besides this 6 here, purple doesn't get any more 6s, which is kind of interesting. That means this can't be a 6. Okay. So the reason this can't be a 6 is because we cannot put another 6 into green, right? We already have 2 6s in green, first of all. Hold on. We have 2 6s in green. We need 2 6s in purple. Did I think about this wrong? Or maybe I'm thinking about this wrong. I'm sorry. The other thing I want to think about is these 2 cells, because these 2 cells are not orange or blue, but we do need whatever orange and blue aren't. I need 2 of those. Okay, so that's the key. That's the key. That's what I'm missing. Is it? I think this extra 1 is gonna be key here. I'm trying to get. I feel like there's like another conclusion I can make here, which I'm failing to grasp. Okay, can we argue that we don't get any more 2, 3, 4s in purple? I think that might be the argument to make. Yes, because I can't fit any more. Okay, well, whatever orange and blue are, we can't fit more orange and blues into purple. I think that much is clear, right? Because we have an orange-blue pair here, and then we have the other orange and blue here somewhere. There's just not room for another orange-blue. They can't go here, and they can't repeat here. So whatever the 2, 3, 4, the orange-blue ends up as, they can't go in purple at all anymore. So no more orange and blues in purple. So I think that might be the other conclusion. For now, we might be able to do more Sudoku. So let's just, getting this 6 might have been good. We know these are 1, 2, 3, 4s that aren't the orange-blue. So one of them is a 1. Right? We know one of these 2 is a 1, because if it wasn't, then we'd have 4, 2, 3. Yeah, just by the quad, one of these is a 1. Okay. So that's not entirely interesting, is it? It means we do need another 1 in purple. But I think there's a few places it could go. So, all right. Well, we got this 6. I'm not sure if we can get this 6 over here. I don't think I proved we can. So what does this 6 do for me? Is that enough? Maybe the fact that this couldn't be something is helpful as well. Right. So the other conclusion we can make is, let's see, can we make a conclusion? We don't know which one's mirrored where. It's kind of the issue. I could give the other 1, 2, 3, 4 as a color. We could call this one yellow, and we could call this one purple. No, we already have purple used. I could call this one gray. Is this 6 enough? These two 6s look up. There's a 6 in one of these two. What does this column need? This column needs 1, 2, 3, 4, 6, and 8. Right, we know the 6 is up here. Can't say much about 8s. I really want to deal with that 1 degree of freedom. I'm not sure how. 3, 3. So the 1 degree of freedom I'm talking about is the fact that we know we need these 10 digits to appear in purple, but there's 11 open spots in purple. So is there some conclusion we can make about needing 2 5s, a 6, a 7, 2 8s, and 2 9s? Wait, we need 2 6s as well. 2 5s, 2 6s, a 7, 2 8s, and 2 9s. Well, there's a 5 in this row already. So if we need 2 5s, they're going to end up here. They're not going to end up there because of that 5 there. So we're going to have a 5. We're going to have a 5 in one of these two. The rest of the box can't be 5. We're going to have a 5 around here. So this can't be 5. We already knew that. So really, it's 5 in one of these two. Was that already known? That's already known by Sudoku. So 5 doesn't help. 2 6s. We know one of them's here. We get one more 6 in one of these cells. Not here because of that 6. Not here because of that 6. We have that 6 is over here. We could end up with a 6 here and a 6 up here. So I don't think this matters. So we're going to end up with 2 5s and 2 6s up here. We need a singular 7 somewhere. That doesn't seem hard to fulfill at all. We need 2 8s. This 8 looks down. None of these are 8. These aren't 8. Okay, so 8 goes in any of these. We need 2 of them. That's not helpful though. Okay, and we need 2 9s. Again, I don't think the 9s are going to be helpful. Okay, so I don't think we can use this yet. We need to find out what the other non 2 3 4 digit is in this row. It's interesting that we know it's not a 6. But I guess that's okay. Okay, I'm probably just missing some Sudoku here. I got this 6, or maybe there's another conclusion from this set that I haven't thought about. I'm looking for more Sudoku to do here. Okay, wait. Isn't there... See, we've got 2 2s, 2 3s, and 2 4s in purple. The one that's not these two. So let's call it, I don't know if it's gray or yellow. Let's just call it yellow. I don't know which one ends up there. But the yellow one, we're going to need 2 of them. I think that's the key. I think the other yellow ends up here. We know this is the second one, right? But not that it matters, but it does mean there's at least 2 1s. That means there's 2 1s in purple. But the one that's extra ends up down here. So how could we have a 7 down here? We can't. I don't know why this is working out this way, but not the other way. I'm getting a little confused. But anyway, so this can't be 7. These are from 2, 3, 4. That's not a 4, that's not a 3. And whichever one of these is the non-1, it repeats down here. Definitely. So we know that for a fact that these cells and these cells, 1, 2, 3, 4, 5, where's the other one? Oh, and these cells, other than where the 1 is, account for our 2 2s, our 2 3s, and our 2 4s. So we're going to need, I think that's the key. That's the key that I wasn't thinking about. Because not only do we have these cells, right, that I was talking about, we have an extra 1 in the green set. And the extra 1 in the green set also needs to go in purple. So the remainder of purple is 1, 5, 6, 7, 8, 9. So all of these purples must be from 1, 5, 6, 7, 8, 9. Notably, they can't be from 2, 3, 4. Because we can't fit more 2, 3, 4s into green. That is the conclusion that I kept dancing around. I'm sorry it took me so long to come up with. Hopefully it was still helpful. 6, 7, 9 is gone. 6, 8, 9 is gone. 5, 6, 7 is gone. 1, 5 is gone. 1, 5 is gone. Okay. So clearly this is the conclusion I was missing. Now the question is, what do we do with that? So 2, 3, and 4. Okay, so this row has a 2, 3, 4 triple. So 1, 2, 3, 4. This is 5. 5 in this row can only go here now. Yeah, that's definitely true. These 2 5s looked in. So actually, I could have placed that 5 a while ago, I think. That's not 5. So the 5 goes here in this box. These aren't 5s. I don't think I need my colors anymore because I have them all penciled in. So let's just get rid of that. That'll make it a little easier to scan, I hope. I got this 5. So 5 in this box is one of these 2. Again, this row has 1, 2, 3, 4, 5, 6. We need 7, 8, 9 in it. This column needs 3, 4, 7, 8, 9. That's too many. No, it's not. It's 3, 4, 7, 8, 9. 3, 4, 7, 8, 9. So this is not 4, 8, 9. Let's clean up a little bit. 3, 7 seems suspicious. Not sure what to do with it right now. Huh. Still not immediately clear to me how this collapses. What do we need here besides 1, 2, 3, 4? We need 6, 8, 9. No, not 9. So we just need a 6 and an 8. Okay, so 6 in this column. Yeah, is up here. I already knew that. Okay. This is a 6, 7, 8, 9 quad. There we go. So this is a 2. That's not a 2. So 2's in one of these 2. These are from 1, 6, 7, 8, 9. So the 1, yeah, the 1's over here. So this has to be from 6, 7, 8, 9. So this is 7, 8, 9. Can't be 6 or 8. 7, 9. Did I miss something from the exo set? Maybe. The problem is I don't know which of these is tart. I don't know which of these. Sorry, I don't know which of these ends up here, so I can't like do much about that. Maybe at some point we will realize what goes there and that'll help, but this can't be 4. Okay. This can be 2. Can't be 3, 4, 5, 6, 7, 8, 9. Okay. 2 isn't one of these two. So this is a 3 or a 4. That's a 3, 4 pair there. Does that help me? These can't be 3, 4. So they're not 1, 2, 3, 4. So they're from 5, 6, not 6, 7, 8, 9. Cleans up quite a bit. 5, 7, 7, 8. Six, 7, 8, 9 is almost here. No. 3, 4 pair. Make sure I did that. Yep. Oh, the basics here are really. I'm struggling. I don't think I should be, but maybe I should have left the set around. I don't know. How about this row? What does this row need? We need a 1, 3, 4, 6, 7, 8. Not 8. That's a 1, 4. That's a 1, 7 pair here. Okay, let me just double check that. This can't be 2, 3, 4, 5, 6, 8, 9. Yeah, so 1, 7 pair puts a 4 here. These aren't 4. That's not 1 or 3. We're left with a 1, 3, 6, 7. That makes sense. So the rest of this column is 1, 2, 8, 9. These aren't 8s. That's not 1. That's not 1. So the 8's down here. One 7 pair means this is a pair. We don't need those corner marks. So this pair, 1, 2, we need 3 and 9. Okay. Not immediately helpful. Over here, this is a pair. It involves a 6. What else? 6 and an 8. So this is from 1, 2, 3, 4, and it can't be 2. Okay, this is a naked single 1. It can't be 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So that's a 1. That's not a 1. That's not a 1. Okay, so we found the 1 in this row. It goes here. So now we know this is our extra digit. Okay. I'm not sure if that helps immediately. This is a 2, 3, 4, so 4 is in one of those two. 2, 3, 4 here, we got that. That was from the exo set. These can't be 2 or 4, so these are from 3, 7, 9. In fact, that's not 3. So this is a 7, 9 pair. So this is the 3. That's 7, that's 7. That's 9, 8. Okay, 1, 6 pair. Oopsie. Oopsie. Okay. Let's clean this up. That's not 7, 9. That's not 7. Okay, this is a 4. This is 6 and 8, 1 and 7. We get the 3 and the 4 down here. We get the 2. 8, 9, that's a 3. We get the 9. We get the 2 and the 1. We get our 3, 4, and 3. That's a 2. So that has to be a 2 by our exo set. Oh, I wanted to use it. All right, so that's 4. That's 7. That's not 7, 9. That's not 3, 7. That's 6 and 1. That's 9, 1, 3. Those aren't 5s. So we get the 9's here, the 7's here. 7, 8, 9, 6, 7, 8, 9. Okay, so that's the 9. 8 and 2, that's 4, 3. 7, 9, 8, 9. There we go. Okay. 5, 7, let's see, 1, 2, 3, 4, 5. So the 4 goes here. That places our 8. This is 5 and 7. That's 6 and 5. We get the 6 and the 8. Over here we need 7 and 9. And we're done. All right. I feel like that could have taken me a lot less time, to be honest. I had trouble analyzing the set properly because what I didn't realize is we knew what the bonus digit was, which was the 1. Realizing the 1 had to be in one of these two was super key to realizing that this had to be a 2, 3, 4 triple. Otherwise, you could have had like a 7 in there. So yeah, it was definitely an exo set based set logic thing. And I couldn't quite get there, but hopefully my thought process helped you. And of course, if you enjoyed this, why not leave a like, subscribe, and a kind comment below.